Welcome 10,000 subscribers and everybody else watching this on YouTube. To commemorate the occasion of turning 10,000 subscribers, I have an engineering special for you. Engineering detail on Honda's electronics and dual clutch transmission. This didn't quite fit the review of the Africa Twin. So in this video I have some additional detail on the using and living with the dual clutch transmission. Some of the questions I see on YouTube: is this bad transmission, or can this be destroyed, or what are the drawbacks or disadvantages of this? So we're going to go over this, as well as, because this is an electronic transmission, I'm going to include some of the electronic systems on the bike. I know in my review haven't mentioned anything about this G button. Also there is other buttons on the handlebar here that especially the S setting. I'm going to look at that one as well. Over here on the computer screen I have downloaded the PDF version of the owner's manual, or as Honda calls it, the operation guide. This is page 62 of the original publication, and in the middle of the screen now I have a schematic or a diagram of the riding modes of the motorcycle. This is important because this understanding will bridge into, or segues into, fully understanding what the dual clutch transmission does for you. Okay, so that's why this is important. You can already see on it there is automatic transmission mode and there is manual transmission mode of the dual clutch model. Okay, so this is all the dual clutch model, and you probably noticed on or during the test ride that I had neutral, S, D and empty buttons on the handlebar, as well as these showing up on the dash. So a couple of myths here. D does not stand for dirt. S does not stand for street. What they actually mean is explicitly written here in the manual. It says D mode is for drive. Okay, it's not a car, but it's the same idea. So they just labeled it D. This drive mode is for regular operation of the motorcycle, okay? And then we have 3 levels of S mode, and it stands for sporty riding. Focus is on the sporty. So yes, it's meant to be a street-oriented thing, but the focus is on sportiness and responsiveness and throttle response. So, and that's why that's what any of these buttons have to do with. It's the computers changing the throttle response or the throttle map. Okay, you have levels 1 and 2 and 3, and over here you can see that the design idea with this S mode was you can select it when you need more power. What they mean by that, when you need more acceleration, okay, such as when overtaking or passing other vehicles, so you need more acceleration. Climbing hills, you need more acceleration. And pulling away, meaning merging with the traffic from standing still, so again you need more acceleration. So the S mode has 3 levels of adjustment, and this is how it kind of looked like on the dash right next to the D mode, the drive mode, when 3 of those bars are lighting up or lit up. And what these levels here mean, so you can just toggle level 1, level 2, level 3, and then back to level 1, level 2, level 3. It's an endless loop. And the throttle response that the computer produces in D mode is very, very conservative, and that's exactly what I've found. That it doesn't allow the engine to be revved up, it shifts up immediately. In sporty mode, however, you can see that you can have 1 bar, 2 bars and 3 bars showing, and what this means is that the more bars you have here, higher engine RPM can be used by increasing the level. Okay, that's written in half Japanese. What they mean by this is that the more bars you have, the more engine RPM you can get in any given gear before the computer off shifts. So what this means is that where this one is very sedentary riding and just brrr, and it's already upshifts, brrr, and already upshifts. This one you can, when you crank the throttle, it's gonna rev up a little bit higher than in D mode. It's gonna be revving up higher, accelerating with a little more liveliness, and then upshift. This one is even more so, and this mode is even more so. So I think I spent most of my time riding in S mode with 3 bars showing. That's when you can rev out in more into a higher RPM range and have more torque and more acceleration going, and I found that in this mode, this is when the bike is most suited for city riding, and maybe not zigzagging in the lanes, but the type of responsive riding that I need for city riding. And even so, I switched back to manual transmission mode on the dual clutch model and changed gears with the plus and minus button to make the throttle response even more markedly sharp, to allow the engine to rev even higher. So with this one in mind, there is one more button, the G button. Now G is for dirt. G stands for gravel, and I'm going to explain how the G button and its functionality relates to the operation of the dual clutch transmission. For the next bit, we're going to go outside again, and I'm going to focus on one aspect of the dual clutch transmission. And that's a wiring diagram, it's control. How the input sensors and how the control of the dual clutch transmission is done, because what comes in from all of these sensors is very particulate, and understanding what the dual clutch does for you has to do with what goes into the computer, because the computer does the shifting for you. So let's take a look at it outside. So let's move on to discussing Honda's dual clutch transmission, starting with how the dual clutch transmission is integrated with the bike's electronics. This integration with the electronics is critical in understanding the do's and don'ts of dual clutch ownership. From then on, I'm going to move on to the disadvantages and advantages of dual clutch transmissions, and ways to save it, ways to destroy it. It's the same idea, as well as what is a dual clutch transmission's expected performance or life expectancy in city riding, in highway riding, or in off-road use. So for this segment on the dual clutch, I'm going to contrast and compare the dual clutch occasionally, and reference it here is Africa Twin's standard clutch or manual clutch here. That's cable operated just like so, so the operator has to do that. The dual clutch transmission has 2 clutch packs in it, one in front of another. They have exactly the same clutch plates and friction discs as in a standard. Both of these are multi-plate wet clutch systems. So this is a manual clutch that's shifting electronically, and it's a manual clutch that's shifted by you. So how does the computer know when to shift and shift up or shift down, or what to do? This whole thing hinges on a couple of input sensors that run information into the computer, namely throttle and brake. You twist the throttle and you make an angular turn here on the throttle. You're pulling on these 2 cables. These 2 cables are braided steel cables that run down there to the throttle body. You can see that when I'm twisting on the throttle, it produces rotation on the throttle body's shaft. The throttle body's shaft is at the center of rotation there, with that nut at the center that the technician tightened and painted white after tightening. On this shaft, on the other side, there is a throttle position sensor. That throttle position sensor is critical to this dual clutch transmission, and also that you don't knock it out of alignment. You can see it mounts with 2 oval shaped holes that are on its left and right flanges. The holes are made oval, so the sensor can be adjusted up and down vertically, as well as side to side a little bit, and it needs to be in perfect alignment with the throttle body's shaft. This throttle position sensor is mounted on the same shaft that runs through the entire length of the throttle body there. So what happens when you twist the throttle is that the throttle position sensor is like a volume knob on a radio. Okay, more turning, more sound at the speakers, even more turning, even more sound at the speakers. So something like that. The throttle position sensor is a variable resistor that sends more and more and more, or less and less and less current to the computer. The computer lives, the electronic control unit, ECU, lives under the seat somewhere. The same idea on the wiring diagram looks like this. You can see in the bottom right hand corner that there is a throttle position sensor, and it's depicted like so. In the middle of it there is this zigzag line, which means this is a variable resistor with a movable electrical contact point on it that slides along it. So when you twist the throttle, this varies the amount of current flowing through the resistor. When you trace where these three wires lead, two of them end up in the ECM, so electrical control module, not electrical control unit. So this is ECM for Honda, so they plug in there. This is a big plug with about a dozen wires into it, and that's another big plug on the ECM. The third wire goes to the ignition switch over there. It receives the signal from the throttle position sensor, and this is what it does with it. If the computer reads that you're opening the throttle more and more and more and more and more, then the computer interprets it that you are accelerating. If you are accelerating, you're gonna be upshifting. In the dual clutch pack here, it selects the next gear up and shifts up for you as the load increases on the engine, as you keep opening the throttle. If you keep opening the throttle more and more and more, again, it pre-selects another gear for you to shift yet again up, and so it keeps going. The computer also has a watch in it, a very straightforward watch, just a stopwatch in it. So if you open the throttle aggressively, then it's gonna upshift for you aggressively. If you upshift at a leisurely pace, it's gonna upshift for you in a casual, leisurely way. Downshifting, of course, is done the opposite way. So you're cruising at a certain throttle opening, and say you have a stoplight or something, and you for whatever reason you're slowing down and you're closing off the throttle. That is sending less and less current from the throttle position sensor to the ECU, and the ECU is therefore interpreting it as you're slowing down, so it downshifts for you. Okay, very straightforward. Now usually this downshifting is accompanied by applying the brake, either this one or this one, and there's in line somewhere there's a pressure sensor. That pressure sensor in the brake lines is also sending a signal to the computer. So if the computer reads that from the sensors the input is that you're decelerating and also applying the brakes, it's gonna downshift for you. Very straightforward. Just based on these three parameters: pressure, the current coming in from the throttle position sensor, and time. So that's how this works. So that's how the computer knows whether to upshift or downshift for you. In some cases, it's possible to confuse the computer. Say you're upshifting or accelerating with the brake engaged, or you are decelerating, you're coasting to stop, and then the light suddenly turns green, and then you accelerate suddenly. So in those cases, it may take a few more milliseconds for the computer to change its already pre-selected gear and reselect another one. But this is all done within milliseconds, okay, very smoothly. So that's how the computer knows which gear to select. Dual clutch transmission is a brilliant mechanical engineering solution here that minimizes clutch plate wear. What are some of the disadvantages? It's got some added weight to the bike, the added cost, the added mechanical complexity, the added extra servicing. it needs the throttle position sensor in top of the line condition, and because everything is done electronically, if any of the wiring harnesses or connection comes loose or rattles loose, or the throttle position sensor needs to be in its exact position, if it shifts or whatever, then it's not going to work for you. Then you're stuck, totally stuck with it. It probably won't shift or won't work at all, or will work really badly. So it's highly dependent on the electronics. But besides that, I think it's very well worth the extra money. Even if you like shifting and you like using your hands, I get it. But this, as an engineering solution, Honda really hit it out of the ballpark with this one. This is very well thought out, superbly engineered, and is just superior to the manual cable pull or hydraulic pull clutches, just manual clutches in general. What are some of the benefits of it? It shifts really fast. Now, why did Honda decide to put it on a bike that's not meant for racing? So fast shifting is important in racing, just as it's important for safety in off-road riding. It's really important that you don't have a power lag between two gears, especially going uphill. Also downhill, but especially trying to pull yourself out of a turn or going uphill. So that's where the dual clutch transmission really shines. And Honda really hit this one out of the ballpark with this dual clutch transmission. Thumbs up. And this is why. One of the other benefits of the dual clutch transmission is that there is less wear in it than in a manual clutch. In a standard or manual clutch, it is possible to slip the clutch wrong. Slipping the clutch means that you're pulling the clutch lever partially, but you're also twisting the throttle a little bit. This situation happens when you are inching in traffic, just inching, not coming to a full stop, just inching at a walking pace or some such speed. Also, remember your motorcycle skill testing or skill course, you had to go around cones. In some of those situations, it's also, or doing a slow U-turn, you have to slip the clutch. If clutch slipping is done with too much revving, then a lot of friction will be generated in those clutch plates, the friction discs and the clutch plates, and the clutch plates will wear unnecessarily while slipping the clutch. This does not happen. Any kind of incompetence and rider incompetence does not happen with the computer. The computer will select first gear for you and will engage the clutch in first gear as soon as possible, but if it has to slip the clutch, it will slip the clutch, just the bare minimum necessary to slip the clutch. So there is less chance of rider error and there is a less chance of clutch wear in this one. So let me explain a little bit here what happens with slipping the clutch. Inside the clutch there are these clutch plates and friction discs. Not the same size. This is from another motorcycle. You see you have one set of smaller discs and another set of bigger ones, about this size. And then you have more of these as well, maybe 3 times as many. So this is how a clutch plate looks like. Let me just get you a close-up. It's got this dimpled surface there with these internal teeth. And this is a friction plate that has these rectangles on it that are bonded to this plate, and these rectangles are also covered in a little bit of a paper towel fuzz, if you look carefully, because this is of course oily and I needed to clean it. So paper towel fuzz of course is not part of the assembly normally. These rectangles here, you can see they are in principle, they work like brake pads on brake rotors. They are some kind of synthetic compound that provides friction. Okay, that's the idea. So that one on the friction discs or friction plates here, friction discs. So in normal operation, when you are in gear, these plates are forced together by spring force and they rotate at the same speed. Once you're slipping the clutch under load, the spring force that holds these together to make them rotate at the same speed, that spring force relaxes a bit. That little bit of relaxing of spring force makes these spin at different speeds. Say these friction plates with these tabs, they will spin and slip along the sides of these clutch plates. Okay, I hope that makes sense. All of these are, I can't spin all three of them at the same time. Sorry, fingers don't work that way, but they all rotate together, but at different speeds. So the plates will have a different speed from the friction discs, because now you are slipping the clutch. So that means that these pads here will begin to slip on the sidewall of these plates. Okay, as the spring force is relaxed a little bit, because you're just inching in traffic. Here's another example of the computer slipping the clutch for you. It has to do with this G switch functionality. Now G stands for gravel, but it relates to off-road riding. This G switch, found on the right hand side of the instrument panel there, just above those two throttle cables, right next to the rear ABS off button. You can find this G switch. It's either off or on, very straightforward. What it does is described here very briefly. It says, so again, for off-road riding, and it reduces the amount of clutch slip during throttle operation. Now, this reduction of clutch slippage is only possible, of course, in this dual clutch transmission. Standard bikes can't possibly have this switch and this functionality. So what this, how this looks like, that it reduces clutch slip during throttle operation, means that when you crank on the throttle, you operate the throttle, it's going to close the clutch plates together real fast. By ramming them into each other, torque is transmitted suddenly to the chain. It yanks on the chain, it spins the rear wheel, it throws dirt everywhere in the air, motorcycle and you. However, this provides low speed control of the motorcycle in bad traction or minimal traction conditions, as well as it's a win-win. It saves your clutch plates as well, as much as they can be saved. So it reduces, or maybe I should say it minimizes, the amount of clutch slip, okay, by closing the clutch plates, all of them, and there's no slippage. There is wheel slippage instead of clutch slippage. So this G-switch works only off-road. If you try it on road, on dry pavement, on asphalt, if you spin the wheel, the rear wheel, it's gonna wear your tire real fast. It's not gonna work out well, okay, for your tire budget. So that's what this G switch does. It goes a long way to extend the life of your clutch plates and eliminates potentially rider input errors on a standard or a manual transmission, where you could be revving the engine and slipping it too much, maybe, some such thing. So computer doing the work for you, minimizing clutch slip, extending the clutch plate's life. So this slipping the clutch and revving the engine is possible on a manual. Is it possible on a dual clutch transmission? No, it's not. The computer is doing the thinking for you and is doing the shifting for you. And if you are inching in traffic, it will slip the clutch for you, but it's not gonna rev the engine with it, even if you try to, because as soon as you hit the throttle aggressively, signal goes to from the throttle position sensor to the ECU. It's gonna close the clutch pack and it's not going to be slipping it. Also, on say this is a track use bike, so I'm gonna go away from that Africa Twin for a little bit. It's easier to film on this one. You know that in MotoGP, out of a clutch you can get 2 start practices. Why is that? Because at start you're slipping the clutch. The clutch again is partially disengaged, and the throttle is revved, the bike is revved at the 7, 8, 9,000 RPMs, whatever, something like that. That's how the bike is launched, by slipping the clutch. Slipping the clutch produces so much heat and friction and so much wear in the clutch plates that after 2 starts, a MotoGP bike's clutch needs to be unbolted, disconnected, removed, the entire clutch completely replaced, a new clutch put in, including new friction discs and new clutch plates, everything bolted back on and buttoned up. So that's why slipping the clutch and rider incompetence can destroy a manual clutch, but it's not so much possible for a dual clutch transmission, because the computer's safety, that it does the shifting and it does the clutch activating for you. As soon as you're aggressive on the throttle, it's going to close the clutch pack and you're accelerating and taking off. So when the spring force relaxes totally, and that makes these plates and discs to separate, not spectacularly this much, but this is the idea. At this point, one set is still rotating at idle speed. See, these friction plates are still rotating at idle speed, whereas these plates are stationary and they don't touch each other. That's why only one set of them is spinning. When on this bike you can come to a stop in first gear, because the computer will do this spring force modulation for you. On a manual, you do it with your hand, you're pulling on a clutch cable and you are modulating the spring force from fully in contact to, you can slip the clutch manually as well as be in neutral, or just completely disengage the clutch like so manually. Okay, so the computer is doing it for you, and this is where one more sensor comes in, the wheel speed sensor. So the computer knows that you have come to a stop or you're inching in traffic because it has a wheel speed sensor to tell it so. You can see that there is this disc here mounted on the wheel with these square holes, and there is a sensor that's kind of close to it. On this motorcycle here we have a much better view on this. Here is the disc and here is the sensor in plain view, not covered by mudguard. So that sensor tells the computer, same on the Honda here, it tells the computer that actually in fact you are inching or you have come to a complete stop. If you have come to a complete stop, because the wheel sensors tell the computer so and the throttle position sensor tells the computer so, it will completely relax the spring force and the clutch plates will not slip, even though it shows on the display first gear. Don't worry about it. It's gonna be completely disengaged like so, with no friction force between the plates and the discs. It's gonna show first gear, so you don't have to put it in neutral. It's not necessary. Computer is doing the thinking for you. Okay, I hope this makes sense with these plates and discs and the wheel speed sensor. And also based on the wheel speed sensor input, throttle position sensor and brake pressure, the DCT is impossible to stall because the computer is going to separate the clutch plates when the vehicle comes to a stop in first gear. And you can see the same idea again on the wiring diagram. Right here you have a speed sensor, that's a rotating magnet with 4 magnets on it that generates electricity in this coil here, and that produces some voltage, and based on the voltage pulses that the computer receives, it knows what the wheel speed is. Very straightforward. Now that oil pressure switch is for engine oil, that's not for That's not the pressure switch in the brake lines, that's a different pressure. One more situation, uphill, and you're waiting, say, a red light or something, and you have a ton of luggage on the bike. So that would be also a bad condition, where due to a lot of weight and the angle of incline on the hill, the clutch would need to be slipped. So how is that gonna work? On a standard motorcycle, in those cases, you might stall the engine repeatedly, or you know you have to open the throttle more in order to slip the clutch and stay on the hill. How is that gonna work on a dual clutch transmission? The computer will slip the clutch for you in first gear and either inch forward or hold the bike on the hill. While the bike is being held on the hill in first gear, the clutch is being slipped. So, because otherwise it's going to roll back down the hill. So, in those situations, extra clutch wear is expected or is produced in the dual clutch transmission. So, how bad is that? It is bad, but it's nowhere near as bad as the possibility of rider incompetence, disengaging the clutch or too much or not enough, and revving the engine unnecessarily high RPMs. The computer is gonna slip the clutch the bare minimum possible. Of course, some slip is gonna be necessary, so that would be the condition where clutch wear is gonna be the most severe. Realistically, how many hours do you spend in traffic, facing a hill, with luggage on the bike, and you're 500 pound yourself, expecting the DCT to slip the clutch there for you? You know, if you spend there hours or days, it's probably going to burn through the clutch plates in a few days. But in normal operation, that you have two of these traffic lights in a day, you know, it's not going to be an issue. Because of the computer, the amount of wear is not going to be as excessive or as incompetent as you might get when you try to do it on a manual transmission, trying to balance the amount of throttle opening with the incline of the hill and the weight on the bike, and balance it with the clutch while holding the bike uphill. So it's the DCT is way better and way more capable of holding the bike on a hill than your skills, no matter how skilled you think you are. The computer reacts way faster in thousands of in milliseconds, okay? So Honda engineers, of course, have thought about this, and they went with a design that incorporates a small clutch oil filter here right underneath the dual clutch. The oil is routed so the oil exiting the dual clutch goes through this filter. Underneath this lid there's a filter element there, and removes the friction plate particles from the oil before it's reused and recirculated and goes into the pistons and gearbox and cams and everywhere else. And over here in the same PDF manual you can see the maintenance schedule, and here you can see clutch oil filter clearly printed in it. Footnote number 6 that this is a DTC model only. So obviously standard motorcycles wouldn't get that line item because the part isn't fitted on them. You can see that every time you change oil filter, you change the clutch oil filter, the two of them always together. And every second time you change engine oil, because that's the engine oil line there. So you change oil with two filters, oil only. Oil with both filters, oil only. So that's how this pattern goes. Right above it just happens to be the valve clearance service interval, and I stands for inspect, clean, adjust, lubricate, or replace as necessary. So that's inspection time there. You can see that the service interval is every 12,000 kilometers or every 8,000 miles. So this is how the pattern looks like for oil and filters as well as valve clearances. So valve clearance is every 24,000 K or every 16,000 miles, and oil and filter alternate every 12,000 kilometers or every 8,000 miles. The engine oil filter is protected by the skid plate, so it's not really exposed, and this is the quantities of oil it needs for the oil change. Over here the clutch oil filter is right where we've seen it on the bike, right underneath the clutch, and it's got that filter element and an o-ring and stuff behind the lid. So what can you do on a hill? Shift it to neutral and apply the rear brake, standard procedure. That way the bike is in neutral guaranteed, and there's absolutely no clutch slippage. If you do have to inch forward,
good, my man.
Leave a little gap, inch forward, put it in neutral, step on the brake. Issue eliminated. Very straightforward. Much like the same as with standard manual transmission. If you don't want to be revving the engine unnecessarily high and slipping it and playing with the lever and the throttle and the lever and the throttle and the foot brake and the lever and the throttle, then you can just shift to neutral. How good is it going on a highway? It works fantastically well on a highway because you don't need to slip the clutch. Slipping the clutch is done in a millisecond. There is no slipping, or shifting is done in a millisecond. Changing gears on a highway and cruising on a highway doesn't use much of the clutch. Going in dirt doesn't use much of the clutch once you're in gear. You do have to slip the clutch occasionally at very, very rare occasions, but that's so little that's comparable to the clutch wear in any manual or standard clutches. Okay, so it isn't worse, it isn't more dangerous, it isn't more prone to failure or isn't more risky to purchase this than that. It's actually, like I said, Honda did some really, really brilliant application of this dual clutch technology to incorporate it on this bike, because it's really, really well suited to this purpose. Some other possible clutch solutions would be CVT. I'm very happy they stayed away from it. This is a fantastic solution for this bike. Definitely 2 thumbs up. So that would be the engineering details that I wanted to share about the dual clutch transmission. Just go ahead and enjoy it. It's gonna work fantastically well.